So now that we've identified the elements of the electromagnetic spectrum, the next topic is to talk about what sources we have, what frequencies, what wavelengths and energies, and their effects on living tissue. So remember, the energy is just a multiple of the frequency, and the wavelength and frequency combine with the wave equation V equals lambda F, because electromagnetic radiation moves at the speed of light in a vacuum, we get C equals lambda F. So when you increase frequency and increase energy, you decrease wavelength. But a big part of this is going to be the impact that they have on human tissues, or living tissues. So radio waves, to the best of our ability, seem to have no effect. They pass through us quite readily. Next up are microwaves. Now, they do have the potential to cook us, just like they cook the food, because they are absorbed by water molecules readily, which cause extra vibration, heat up the materials. But unlike what some people will say, these microwaves, which we don't just use to cook with, they are actually used for cell phones as well, absolutely positively do not cause cancer. When we are doing Physics 30, we will talk about how that works. Essentially, you must have a single photon of high energy to cause cancer. You can't get the same effect from a large number of low energy photons. Microwaves cannot do the job. So it's not that they are harmless. They can cook you. But cancer is not on the list of microwave dangers. Infrared is what we perceive as heat energy. And then we have the visible wavelengths. Ultraviolet rays actually fall into three categories. UVA being the lowest energy, UVC being the highest. So these come from the sun. UVA has energies too low to cause cancer. So that's not a concern with UVA, but with UVB and C, cancer is a risk. Although UVC gets blocked by the Earth's ozone layer. So as long as we maintain the ozone layer, UVB rays are the ones we really need to concern ourselves with. As the ozone layer is depleted, then UVC becomes a much bigger concern. Now, X-rays can also be cancer-causing, but you need prolonged exposure. Ultraviolet, in practical terms, tends to be more dangerous than X-rays because X-rays are not found abundantly in naturally occurring processes. Almost all X-rays you've ever been exposed to were made in a lab by a medical device that is specifically targeting a part of your body. They are getting more and more sensitive detective equipment so that it takes fewer and fewer X-rays to take those X-rays, and thereby reducing the risk. So we're looking at a few seconds a year of X-ray exposure, while people will just go out, put on some sunscreen maybe, and lie in the sun for hours with exposure to ultraviolet rays. It's also important to note, ultraviolet rays are not blocked by clouds. So if you're thinking, oh, it's a cloudy day, I don't need sunscreen, yeah, you do. There is almost nothing naturally occurring below the ozone layer that's going to stop an ultraviolet ray. So these UVB rays are coming down just because the sun is out, whether you can see it behind the cloud cover or not. Next up are gamma rays. With that Greek letter gamma, these are the highest energy so far because we are going in order of increasing energy. These can most definitely cause cancer and much, much worse. Thankfully, they need to be, again, high volume because your body does have systems in place to try and correct this. So you do need prolonged exposure to large quantities. And then finally, the cosmic rays are above gamma. These are ones that they would be the most dangerous if they hit us. They've got very high energy. And if we do E equals mc squared to turn energy into mass, a gamma ray might turn into one or two particles, or maybe a dozen as they get to very high energy gamma rays. Cosmic rays come in from space, hit the atmosphere, and produce showers of particles. We are talking hundreds, if not thousands, of particles from this energy, to the point that one cosmic ray can cause a shower that can completely encompass Edmonton. So these have the highest energy, but because they've got such high energy and they come from essentially the depths of outer space, they are not a huge risk because we're not going to be directly impacted by a cosmic ray. What we do see and experience are the occasional bursts of large numbers of low energy particles. And that's something that our bodies can readily deal with.